Functional engineered nanoparticles are produced and used in various branches of the industry. They're used as pigments in dyes and paints of various industrial applications, catalysts and ceramics, in pharmaceutical agents, as well as in specialty chemicals. Nanoparticles are very often applied in wet processes, enter the process waters, and subsequently are released to the environment. The research project has developed a new technology for nanoparticle removal based on electrocoagulation. Electrocoagulation is a process that uses electricity and metal plates to cause nanoparticles to destabilize and precipitate. Here's a description of the technology. The prototype consists of an electrocoagulation unit, an absorption and flocculation unit, and a separation unit. Electrocoagulation takes place in the Electrocoagulation Unit. The wastewater containing nanoparticles flows through the space between parallel electrodes, which are created by ferrous plates. Applying the current leads to the release of iron ions in the wastewater. Ferrous ions react with the hydroxide ions from the electrolysis of the water and form hydroxide flocks, and the nanoparticles are absorbed on the flock's surface. Small hydroxide flocks from the electrocoagulation enter the flocculation unit. In the absorption and flocculation unit, the flocks with absorbed nanoparticles slowly agglomerate, increase in size, and form a dense flock blank. Effluent goes from the flocculation tube to the separation unit. The flow direction of the separation unit is from bottom to top. The bigger flock agglomerations settle to the bottom and are disposed of as hydroxide sludge. Smaller flocks with electrolysis gases flow up to the top. On the way, deflectors degas the flocks of electrolysis gas and hold them back for a further agglomeration with following flocks. Once they reach a certain size, they settle to the bottom. The overflow is free of flocks and therefore free of nanoparticles. The sensor and control system runs the process of the electrocoagulation unit. Its main features include automatic or manual mode, regulate the electricity in the electrocoagulation unit either with voltage or current, and monitors and logs all process variables: pressure, conductivity, turbidity, pH value, flow, current, and voltage. Alarm and warning handling. Here are the advantages of electrocoagulation compared to chemical coagulation. There's no need to store and handle acidic or corrosive chemicals like ferrous or aluminum salts. There are no salts added during treatment, and longer water reuse is possible as anions such as chloride and sulfate will not accumulate. Electrocoagulation flocks are more porous and therefore have a higher absorption capacity per flock volume. The aggregation of nanoparticles in the electric field by polarization effects produce larger particles, improving collision efficiency in subsequent flocculation stages.